Now it's your turn to find the missing exponents and coefficients from two different equations. If you've not tried both parts of this example on your own already, please pause the video, try these on your own, then return to the video to check your work. In part A, we need to find the missing coefficients and exponents of something x to the 15th minus 21x to the 9th divided by 3x to the something, which equals 5x to the something plus something x to the third. Because the coefficient in the denominator was originally given, we'll begin working with the coefficients. The first term in the numerator was something x to the 15th. We take that something, that coefficient, and we divide it by 3, and we obtained 5. Well, we know 15 divided by 3 is 5, meaning the coefficient on the first term in the numerator had to be 15. Separately, the second term in the numerator was negative 21x to the 9th. When we take that coefficient of negative 21 and divide it by 3, well, we know that answer has to be negative 7. So we've now filled in the missing coefficients. We'll now turn our attention to the exponents. As always, we need to find the coefficient and the exponents in the denominator first before we do anything else. To find the missing exponent in the denominator, we need to find an exponent that were given in the numerator and its matching or corresponding exponent in the result. In this case, in the second term, we know we started with an x to the 9th, and we know we resulted with or ended with an x to the 3rd. Well, the only way to do that is if I took x to the 9th and divided by x to the 6th, because x to the 9th divided by x to the 6th would be x to the 3rd. Now looking back at the first term, we had an x to the 15th. When we divide that x to the 15th by the x to the 6th, we will obtain x to the 9th. So it looks like we've filled in all the missing exponents and coefficients. We'll check our work and complete the directions, which state rewrite the entire equation with the missing exponents and coefficients filled in. To do both at once, we'll start by writing out the original numerator with the missing pieces filled in. So we have 15x to the 15th minus 21x to the 9th divided by 3x to the 6th. But to check our work, we'll actually carry out this division and then verify it matches what we had on the right side from our initial work. 15x to the 15th divided by 3x to the 6th. 15 divided by 3 is 5. X to the 15th divided by x to the 6th is x to the 9th. The second term, negative 21x to the 9th, divided by 3x to the 6th. Negative 21 divided by 3 is negative 7. X to the 9th over x to the 6th is x to the 3rd. So we obtained 5x to the 9th minus 7x to the 3rd, which matches the work we had originally done. In part B of this example, we have 6t to the 15th plus something t to the 12th minus 18t to some power, all divided by something t to the something, and that will equal 1/2 t to the something plus t to the 5th plus something t to the 3rd. There are a lot more somethings in this example, but again, we'll simply start with either exponents or coefficients. On this example, we'll just choose to start with the exponents. As always, we need to find the exponent in the denominator first. So we begin by looking for the exponent that was given in the numerator and has a corresponding exponent in the result. On the second term, we can see that we start with t to the 12th and we finished with t to the 5th. T to the 12th divided by t to the 7th would give us t to the 5th. That tells us the exponent in the denominator is 7. We can now go back and fill in the other missing exponents. The first term was 6t to the 15th. Ignoring the 6 but focusing on the t to the 15th. T to the 15th divided by t to the 7th would give us a resulting t to the 8th. In the third term, negative 18t to the something. When we take that t to the something divided by t to the 7th, we obtained t to the 3rd. Well, that means we would have had to have started with t to the 10th, because t to the 10th divided by t to the 7th is t to the 3rd. With the exponents now filled in, we'll turn our attention to the coefficients. And again, always starting by finding the coefficient in the denominator, and then filling in the other missing coefficients. To start, I need to find a coefficient that I was originally given in the numerator, and whose matching or corresponding coefficient was given in the result. The first term started out with a coefficient of 6, and ended with a coefficient of 1/2. I know that 1/2 is the same thing as 6 over 12, so 12 has to be the coefficient in the denominator. Looking at that second term, we had something t to the 12th. When we took that something t to the 12th and divided by 12t to the 7th, we obtained t to the 5th. We need to remember that t to the 5th means 1 t to the 5th. So 1 is the same thing as 12 over 12. The coefficient in the second term in the numerator must be a 12. And finally, the third term was negative 18t to the 10th. When we take that coefficient of negative 18 and divide by 12, negative 18 over 12 is the same thing as negative 3 over 2. We now have all the missing pieces, so we'll finish off the same way. We're going to write the entire equation, but we're going to also check it as we do this. So 6t to the 15th plus 12t to the 12th minus 18t to the 10th, all divided by 12t to the 7th. We're going to go through and do the division. 6t to the 15th over 12t to the 7th. 6 over 12 is 1/2. T to the 15th over t to the 7th is t to the 8th. The middle term was 12t to the 12th divided by 12t to the 7th. 12 divided by 12 is 1. T to the 12th divided by t to the 7th is t to the 5th. And finally, negative 18t to the 10th over 12t to the 7th. Negative 18 over 12 reduces down to negative 3 over 2. T to the 10th divided by t to the 7th is t to the 3rd. We can now check the right side of our equation, 1/2 t to the 8th plus t to the 5th minus 3/2 t to the 3rd, and check that it does match the work that we had originally had in our scratch work on the left side of the paper.